Welcome to the Network and Cybersecurity lecture series. Myself, Darshan BD, Assistant Professor, Department of ECE, SJB Institute of Technology, Bengaluru. The Network and Cybersecurity subject code is 17EC 835. This subject is professional elective for 8th semester students. In this subject, we are going to study the network security concepts and also a cyber security concept. It consists of 5 modules. First 3 modules covers the network security concept and another 2 modules covers the cyber security concept. Module 1 is transport level security. In that we are going to discuss web security consideration, secure socket layer, transport layer security, HTTPS and secure shell protocols. First, considering the web security consideration, in that we are going to study web security threat and different web traffic security approaches. In secure socket layer, we are going to study the secure socket layer architecture, secure socket layer protocol stack and secure socket layer record protocol operation. Then we are going to study the chain cipherspec protocol, alert protocol and handshake protocol operations. In transport layer security, we are going to study the hash function and some cryptographic function. Next, hypertext transfer protocol for secure. In that we are going to study the connection initiation and connection closure operation. Next, secure shell is called as SSH. In that we are going to study SSH protocol stack. Consider the connection protocol. The secure shell connection protocols runs on top of the secure shell transport layer protocol and assumes that a secure authentication connection is in use. This is the connection protocol is one of the secure shell protocol that works for the secure shell and it is works top of the TCP. The secure authentication connection referred to as the tunnel is used by the connection protocol to multiplex a number of logical channels. Here the number of logical channels or connections we are going to use to multiplex that number of logical channels. Consider a channel mechanism. In this channel mechanism, we are going to consider some the points, all types of communication using secure shell such as terminal session are supported using separate channels. The second point is either side may open a channel. For each channel, each side associates a unique channel number which need not to be the same on both ends. When you are going to consider that the channel mechanism for both sides or each side, so it's associated with a unique channel number. So it need not to be a same at both sides, so it will be different. Channels are flow controlled using a window mechanism. So when you are going to consider the flow control, that we are going to use the window, a standard window size we are going to use so that the flow will be the controlled using that window. If the window size is small, so it will be restrict the flow. Fourth one is no data may be sent to the channel until a message is received to indicate that window space is available. Okay. So when you are going to consider that window, so if the window is free means window size is available means then only we are going to send a data. Otherwise we are not going to send a data. The life of the channel, the progresses through 3 stages. The channel is opening a channel, data transfer and the closing a channel. Always that whenever connection is established means so it's opening a channel is going to send the data transfer which happens, then the closing a channel.
Next point is when either side wishes to open a new channel. It allocates a local number for the channel and then sends a message of the form. Consider the different forms we are going to send. We are wishes to open a channel. Here byte secure shell message channel open. Consider the string channel type. uint32 is considered as unsigned 32-bit sender channel. So uint32 means unsigned integer, unsigned 32-bit integer. Earlier mentioned that. So unsigned 32-bit integer initial window size we are going to consider means so that the 32-bit information only we need to send that. So more than that we cannot send that. So unsigned unit 32 unsigned 32-bit integer, the maximum packet size is 32-bit. So unsigned 32-bit integer, the maximum packet size. Consider the channel type specific data follows that you are considering uint32 means unsigned 32-bit integer. Sixth point, the channel type identifies the application for this channel as described subsequently. When I am going to consider the next point, the sender channel is a local channel number. So sender channel is a local channel number. So it is the initial window size specifies how many bytes of data can be sent to the sender for this message without adjusting the window. Means so we can consider that the initial window size gives the initial data rate that. So only that much size of data we can send it from the sender. Next one is the maximum packet size. So consider the maximum packet size specifies the maximum size of an individual data packet. Maximum packet size specifies the maximum size of an individual data packet that can be sent by the sender. It is also the maximum packet size indicates that the window size. Next is we are having some figure that's going to give the example of the connection protocol message exchange. So in this example, we are going to consider secure shell, the connection protocol, the message exchange. So when you are going to exchange the message, so consider that the client and the server first establish authenticated transport layer connection means so transmission control protocol TCP we are going to use so to connect from the client and server. Then authentication happens between the client and server. That authentication is happen using the transport layer connection. Then so it's open a channel. So main three operation we are going to consider when we are going to exchange the messages: open a channel, data transfer, then close a channel. So we need to so consider so these 3 points. Open a channel. So when you are going to open a channel, so what we need to do? So authentication should be happen between client and server. That's already done. So client going to send a message that message channel open. So for that, so server need to interact. So if the server is so acknowledge like channel open the confirmation. Channel open confirmation means the channel is open. If server is authenticated as a the channel open is failure, like that means the channel is not open. So always when you are going to open a channel, we need to request the server. So that's why we are going to send a the message channel open message. So once the channel is opened, So we are going to send the n number of data. Consider the message format is SSH secure shell message channel data. So we are going to send the data here, that we are going to consider as a data transfer. That will be happen. So after the data transfer, so we need to close the connection, because once it's open the connection means, or open the channel means, so you need to close the channel. So after the data transfer, client going to send a message that the message channel is closed. SSH message channel closed. So for that information, for closing the channel information, the server will not acknowledge. So once the server is received that the channel close means, automatically server will close the channel. So this figure gives the information how that the message will be exchanged in secure shell connection protocol. Consider channel types. Here we are going to use 4 channel types are recognized in the secure shell connection protocol specification. So here you can see that the 4 channel types that we are considering is session, X11, then is forwarded TCP/IP, then direct TCP/IP. So these are the 4 channel types, so that we are going to use it in the secure shell. First one is session. The session, in that session, the remote execution of a program will be happen. The program may be shell as application such as file transfer or email. You are going to use a system command or some built-in subsystem. Once a session channel is opened, subsequent requests are used to start the remote program. Okay, once the session is created, so many connections will be established in that particular session. In that, so we are going to start a remote program also. Consider the X11. This refers to a X window system, a computer software system and network protocol that provides the graphical user interface, considered as a GUI, for network computers. X allows the application to run on the network server but to be displayed on the desktop machine. So next, third channel is forwarded TCP/IP. This is remote port forwarding. Next is direct TCP/IP. This is local port forwarding. So it's remote port forwarding and local port forwarding. That gives the specification for that, the forwarded TCP/IP and direct TCP/IP. Consider the port forwarding. One of the most useful feature of secure shell is port forwarding. In a sense, port forwarding provides the ability to convert any insecure TCP connection into a secure SSH connection. So in that, so we are going to convert the insecure connection to the secure connection. So this is also we are going to consider SSH tunneling. So instead of transferring the information, so direct transfer, we are going to do the tunneling, means direct transfer. A port is an identifier of a user of TCP. Any application that runs on top of the TCP has a port number. Incoming TCP traffic is delivered to the appropriate application on the basis of the port number. So considering some applications, an application may employ multiple port numbers. So in that we need to consider that. So consider the example for the simple mail transfer protocol, we call it as SMTP. The server side generally listen and port number consider the port number is 25. So an incoming SMTP request uses TCP and addresses the data to destination port 25. So transmission control protocol, the TCP, recognize that the SMTP, simple mail transfer protocol, server address and routes the data to the SMTP server applications. It's going to send the server address and routes the data to the SMTP server applications. Consider secure shell transport layer packet exchanges. In that, we need to consider that the connection via TCP and we are going to consider the tunnel connection via the tunneling. So for that, we consider that the client and the server. For that client side, we are considering a client application TCP entity, server application TCP entity. That the connection is established unsecured TCP connection. We are going to consider unsecured TCP connection. Next, we consider the tunnel net. So when you are going to consider the secure shell, the tunneling, in that the client application SSH entity, TCP entity. In between that, the client application and TCP entity, we are going to use secure shell entity. That the secure shell entity, it's going to provide the secure SSH tunnel. So direct, so it's from SSH entity to the server side SSH entity. Afterwards, the TCP entity will be happen. That so you can observe that. So in this, the secure the tunneling will be happen. The basic concept behind port forwarding is the client application that is identified by the port number X and a server application identified by port number Y. At some point, the client application invokes the local TCP entity and requests a connection to the remote server on port Y. The local TCP entity negotiates a TCP connection with a remote TCP entity such that the connection link local port X to remote port Y. That indicates that is a TCP entity there. We are going to consider a to secure this connection. We are going to configure the SSH. Secure shell is configured so that secure shell transport layer protocol established a TCP connection between the secure shell client and server entities with TCP port numbers A and B respectively. That A and B we are going to name it for that SSH client and server entities. A secure SSH tunnel is established over this TCP connection. The traffic from the client at port X is directed to the local secure shell entity and travels to the tunnel where the remote SSH entity delivers the data to the server. So here we are considering that the source entity and at the destination or server side we are also having SSH entities there. So SSH entity you are going to use at the source and destination, or you can consider say client and server. Application of port Y. Traffic in the order direction is similarly redirected. Here, Secure Shell supports two types of port forwarding. One is local forwarding, another one is remote forwarding. Consider a local forwarding. So in that local forwarding, it allows the client to set up a hijacker concatenated with the process. This will intercept selected application level traffic and redirect it from a unsecured TCP connection to a secure SSH tunnel. That means whichever the connection is happens between the client and server using the TCP, we are going to establish a secure connection, that is using SSH tunnel. Consider the example should help clarify the local forwarding. Suppose you have an email client. You have an email client on your desktop and use it to get a email from your mail server via the post office protocol POP. The assigned port number is 110 for the POP3. Considering some ways or points to secure the traffic, so consider that the SSH client set up a connection to the remote server. Second point is select an unused local port number, says 19999, and configure secure shell to accept the traffic from this port distant from port 110 on the server. Consider that secure shell, the client inform the secure shell server to create the connection to the destination. In this case, email server port is 110. Consider that client takes any bits sent to local port 9999 and sends them to the server inside the encrypted SSH session. The secure shell server decrypts the incoming bits and sends the plain text to the port 110. So the port 110 is the server port. In the other direction, the secure shell server takes any bits received on port 110 and sends them inside the secure shell session back to the client, who's decrypt and send them to the process connected to the port 9999. After local forwarding, consider the remote forwarding techniques. The user's secure shell, the client acts as a server's behalf of. A client receives the traffic with a given destination port number and places the traffic on the correct port and sends it to the destination the user chooses that. So we are going to consider a typical example of a remote forwarding is, you can use that you wish to access a server at home from your home computer because the work server is behind a firewall. It will not accept the secure shell request from your home computer. However, from work you can set up a secure shell tunnel using the remote forwarding. So in that time, so when you are having a office server, you need to connect it to office server using your desktop means. So in that time, so we need to tunnel it. We cannot send, we cannot connect that. We need to tunnel it. Consider consider that this involves the following steps. So from the work computer, set up an SSH connection to your home computer. The firewall will allow this because it is protected outgoing connection. Configure the secure shell server to listen a local port, says the 22, and to deliver the data across the secure shell connection addressed to remote port, says 2222 port number. So you can now go to your home computer configure secure shell to accept traffic on port 2222. So afterwards, you now have an SSH tunnel that can be used for remote login to the work server. So you can use the SSH tunnel directly. You can log on to the work server from the home. That you can call it as remote log on to the work server. Thank you.